Welcome to today's class. So in the yesterday's class, I explained about L hospital rule and we did some problems on L hospital rule. And today also I will continue the problems on L hospital rule. So very interesting topics. This is L hospital rule. This is one of the short trick to solve the limit problems. Okay now. So let us see this problem. Limit extends to 0, sin inverse of x minus tan inverse of x upon x cube. As x tends to 0, so if you substitute as x value approaches to 0, so sin inverse of x value approaches to 0 and tan inverse of x value is also approaches to 0. On the whole, numerator approaches to 0, automatically denominator is also approaches to 0. So this is a 0 by 0 form, which is a indeterminate form. Then how to proceed this problem? So then differentiating numerator and the denominator with respect to x. Okay, right. So here limit extends to 0. Sin inverse of x derivative is 1 by root over 1 minus x square minus tan inverse of x derivative is 1 by 1 plus x square by x cube. Okay na, right. So x cube derivative is 3x square, right. Now x tends to 0, substitute as x value approaches to 0. So this is here 0 square, so 1 minus 0, 1, minus here also you will get 1, 1 minus 1, 0, 0 by again 0 you are getting. But let us first simplify this, see what happens. Limit extends to 0. So if you take LCM, this is a 1 plus x square minus root of 1 minus x square divided by root of 1 minus x square into 1 plus x square into 3x square. Okay now. Now here no need further, so you will get a 0 by 0 form, but don't do L hospital rule in this stage. Why? Because if you do L hospital rule here, again you see here u into v into w. So here if you differentiate the denominator, you will get a very big expression. Okay, so don't do that. So instead of that, so let us multiply the numerator and denominator with the here minus is there, no, plus, that is 1 plus x square plus root of 1 minus x square upon 1 plus x square minus plus 1 minus x square. In the numerator, limit extends to 0. What happens? A minus b into a plus b, a square minus b square, 1 plus x square whole square minus 1 minus x square upon root over 1 minus x square into 1 plus x square into 3x square into 1 by 1 plus x square plus root of 1 minus x square. Now let us do a plus b whole square formula. So this is equal to limit extends to 0. So this is a 1 plus x power 4 plus 2x square minus 1 plus x square upon. So this is a root over 1 minus x square into 1 plus x square into 3x square into 1 plus x square plus root of 1 minus x square. Any more cancellations here? Yes, you can simply cancel here. Plus 1 minus 1 cancel, 2x square, 3x square, here x power 4. Take x square common outside and you can cancel here also down. So therefore then you will get limit extends to 0. So if you take x square, so here x square will be there plus 2x square plus x square, 3x square plus 3 will be there, denominator root over 1 minus x square, root over 1 minus x square, 1 plus x square into 3. X square will get cancelled. So this is equal to 1 plus x square plus root of 1 minus x square. 1 plus x square plus root of 1 minus x square. Now substitute x is equal to 0. So if you substitute x is equal to 0 happen, this is 0 by 3. So here 1 minus 1. So here also 1. So 1. This is a 1 plus 1. This is a 1 minus 1, 2 into 3. 3 will get cancel 1 by 2. So root of 1 minus x square. So here 1, here it is a 1, 0, 1, 1 plus 0. This total is a one term. So this is a total is a 1, this is a 0, this is also 0. 1 plus 1, 2 will come, already 3 is there, 3 will get cancelled. 1 by 2 is the correct answer. So very nice problem. This is using L'Hopital rule we solved this problem. Okay. So I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. See the problem. The graph of the function y is equal to f of x has an unique tangent at the point a comma 0 through which the graph passes. Then evaluate this value. So first of all, try to understand the first two lines. The graph of the function. So any curve is there, one curve. The graph of the function has a unique tangent at the point a comma 0. So this is a comma 0, that is lies on x-axis. It has a unique tangent. So that means what? So there is a graph. So it has a unique tangent at the point a comma 0. At this point it has a unique tangent. That means what? So f of a is equal to 0. That means f of a is equal to 0. The image of a is 0. The image of a is denoted by f of a, that is given as 0. So in our due course, wherever we got f of a, we can substitute a. And one more thing what how to conclude is, since one more thing what we have to conclude is, since it has a unique tangent at a comma 0, so at a comma 0 f of x is differentiable. That means that is f dash of x exists. F dash of x exists. It is differentiable. Therefore, its differentiable means what? Its first derivative exists. Okay, right. So let now try to coming to the problem. So what is the problem? Limit extends to a. So substitute wherever x is a, substitute here f of a. So f of a value is equal to how much? 0. 6 into 0, 0. Log 1 is 0. So denominator is also 0. So we got 0 by 0. So we will approach the L'Hopital rule. So this is equal to limit extends to a, log x derivative 1 by x, that is equal to 1 by 1 plus 6 times f of x into, what the derivative of 1 plus 6 times f of x? One derivative is 0, 6 into f dash of x by 6 times f of x derivative f dash of x by 3 into f dash of x. Okay now. Since f dash limit extends to a, now substitute limit extends to a. So this is equal to 1 by 1 plus 6 into f of a into, so this is 6 times f dash of a by 3 times f dash of a. Okay now. So since f dash of a cannot be equal to 0, why? Because, so therefore these two gets cancelled. So 3 1s are, 3 2s are cancelled. So that is equal to 1 by 1 plus 6 into f of a. F of a value is equal to how much? 0. In the numerator you will get 2. Okay now. So therefore on the whole 2 is the final answer. Understand this? Okay. So such type of problems are also giving in the JEE mains examinations. I hope that you understand this solution. Let us move to next problem. Welcome to this problem. This is a limit extends to infinity, x times log of sine of a plus 1 by x by sine a to the base c. So where a lies between 0 to pi by 2. Then what is the here? Observe here, limit extends to infinity is there. So if you generally students what they think as extends to infinity, 1 by x tends to 0, therefore sine a gets cancelled, 1, log 1, 0, extends to infinity, infinity into 0. Infinity into 0 is also an indeterminate form. Infinity into 0 we got, that is also an indeterminate form. But so to apply L'Hopital rule, so we should be in the form of 0 by 0, infinity by infinity, otherwise minus infinity by minus infinity. These are the three formats we have to get, then only we can apply L'Hopital rule. That is differentiating numerator and denominator, but it is not in the form of, this is in the form of infinity into 0, then you should not apply the L'Hopital rule. Then a little bit small change will make this function into 0 by 0 form. See here how we will do this. Limit extends to infinity log of sine of a plus 1 by x divided by sine a whole divided by 1 by x. Now see, observe here. Now as x, so directly you should not do this problem here. So now change it. In the x, can I write down 1 by x? Now you apply here. Limit extends to infinity. So 1 by x tends to 0. So sine a by sine a cancel. Log 1 we will get 0 by, as x tends to infinity, 1 by x approaches to 0. Can we get 0 by 0 form? Yes, we got the 0 by 0 form. Now we are right to apply the L'Hopital rule. Now the differentiate both the numerator and denominator with respect to x. So why? Because we are taking as x tends to infinity. Okay, right. Limit extends to infinity. So this is a log x. Log x means log x derivative 1 by x, 1 by this. So directly I will write down the reciprocal, that is equal to sine a by sine of a plus 1 by x into. So here 1 by sine a is a constant, put it at this, into sine x derivative cos x, that is a plus 1 by x into a derivative 0, 1 by x derivative minus 1 by x square whole divided by 1 by x derivative minus 1 by x square. Understand this? Right. Now is there any more cancellations takes place? Yes, cancellations are there clearly. Sine a will cancel. As x value approaches to infinity, so 1 by x square approaches to 0. 1 by x square approaches to 0, it is not equal to 0. Try to understand here. 1 by x square approaches to 0. 1 by x square is not equal to 0. So here 1 by x square is not equal to 0. Therefore, then we can cancel these two since they are not 0. That's why. Okay, now as x tends to infinity, so substitute here. So as x tends to infinity, 1 by x tends to 0. This will become a cos a. This is a cos sine a. So this is a cos a by sine a. This is equal to cot a. So cot a will be the final answer. Cot a will be the final answer. So I hope that you understand this solution. The first thing what you have to observe is we have to apply the L'Hopital rule when it was a direct substitution. When you do the direct substitution, it should be of the form 0 by 0 or infinity by infinity or minus infinity by minus infinity. But if you substitute x tends to infinity here, we are getting infinity into 0 we are getting, which is not a independent form, but which is not the required form. Then a little bit change I did. So here what the change? X I by 1 by x. Then we can able to do the, now it is of the form 0 by 0. Then we can do the L'Hopital rule. Here we have the right to cancel minus 1 by x square, minus 1 by x square. Why? Because as x value approaches to infinity, 1 by x square value approaches to 0, it never be equal to 0. Therefore, 1 by x square never be equal to 0. Then these two can be cancelled. Then you substitute and we will substitute and we get the answer. Okay. So I hope that you understand this solution. Let us move to next problem. Welcome to this problem. Find the value of alpha so that limit extends to 0, 1 by x square into e to the power of alpha x minus e power x minus x is equal to 3 by 2. So we have to find out this alpha. So alpha is here. Then how to find out? So observe here we are getting a finite value 3 by 2. So we are getting a finite answer 3 by 2 such that what is the value of alpha. Let us move this start this problem like this. Limit extends to 0 e power alpha x minus e power x minus x by x square. Okay, first we will substitute. As x value approaches to 0, substitute wherever x is there, substitute 0. So here e power 0, 1, 1 minus e power 0 1 minus 0 by 0 square 0 on the whole 0 by 0. We get 0 by 0. Then we can apply the L'Hopital rule. So what is the L'Hopital rule? Limit x tends to 0, e power alpha x derivative is e power alpha x derivative alpha minus e power x derivative e power x derivative minus 1, x square derivative 2x, x square derivative is 2x. On the whole, now you substitute x is equal to 0 here. So again e power 0 1. So here e power 0. So 2 into 0 2. 2 into 0 infinity. So but you are not getting 0 by 0 form. So don't try to again you apply the L'Hopital rule. Don't apply. Why? Because here as x value approaches to 0. So here e power 0 is alpha minus e power 0 is 1 minus 1. So it is not equal to 0. It is not equal to 0. We are not getting 0. That's why. So don't apply the L'Hopital rule. But observe here we are getting a value 3 by 2 finite value. We know that as x value approaches to 0, 2x value approaches to 0, that is denominator approaches to 0. Therefore, numerator also approaching 0. So, why? Because we are getting a finite value 3 by 2. As the denominator approaches to 0, the numerator also should approach to 0, so that we will get 0 by 0 and we will apply the L'Hopital rule and we will get a finite value 3 by 2. That means this numerator, what is the numerator? Alpha into e power alpha x minus e power x minus 1 should be equal to 0 as x value approaches to 0. So substitute wherever x is there, substitute alpha into e power 0 minus e power 0 minus 1 is equal to 0. That is alpha minus 1 minus 0, that is alpha is equal to 2. E power 0 is equal to 1. So as the denominator we are getting a finite value 3 by 2. As the denominator approaches to 0, the numerator also should approach to 0. Understand? That means the numerator should be equal to 0 as x value approaches to 0. That's why we substitute x is equal to 0 and we got the alpha value. Okay now. So very logical problem this is. I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. Let us try to see the problem. Limit x tends to 0, sin x plus log of root of 1 plus sin square x minus sin x upon sin cube x. Okay, as x value approaches to 0, substitute sin 0 is 0. So this is a 0, this is 0. Root of 1 plus 0, 1, 1 minus 0, 1 log 1 is 0. On the whole, numerator you are getting 0, denominator also you are getting 0. Okay now. Now can we start directly L'Hopital rule? So if we start directly L'Hopital rule, the problem will be very difficult. Why? Because so instead of that, so let us do in a technical way. What the is put sin x is equal to t. Put sin x is equal to t. As x value approaches to 0, as x value approaches to 0, sin x value is also approaches to 0. Therefore, t approaches to 0. T approaches to 0. That means in place of sin x, we put t. So therefore, the problem will become x tends to 0 will become t tends to 0. The sin x is a t plus log of root of 1 plus t square minus t divided by t cube. So this is the our problem. Now here, what is the technique that we you got this from this problem? The total sin x problem after substitution it became a another form. So doing this in this problem comparatively this is very easy. Okay now, right? Now if you substitute t is equal to 0 here also you will get 0 by 0 form. Okay now. So now do the L'Hopital rule. So here also you will get 0 by 0. So what is the derivative? Limit t tends to 0, t derivative is 1. Log x derivative 1 by x, that is a 1 by root of 1 plus t square minus t into root x derivative 1 by 2 root x, 1 by 2 root of 1 plus t square into 1 plus t square derivative, 1 derivative t, 2t minus 1. Understand this? Whole divided by t cube derivative 3t square. First, let us simplify this. Any more cancellations? So, I am seeing one cancellation here. 2 will get cancelled. Okay, now. So, let us do the cross multiplication here. So, limit t tends to 0, 1 plus. So, if you do the cross multiplication here, become t minus, it become t minus root over 1 plus t square. T minus root over 1 plus t square by so this already there, 1 plus t square minus t already there into root over 1 plus t square. Understand? So, any more cancellations? By 3t square is there. So, by 3t square. Okay, now. Any more cancellations? If you observe, t minus root of 1 plus t square, root of 1 plus t square minus t. So, these two can be cancelled. Of course, minus 1 will come, remains. Now, the problem is, final problem is limit t tends to 0. So, this is equal to 1 minus 1 by root of 1 plus t square divided by 3t square. Understand? So, here this 2 can be cancelled, it will remain minus 1 by root of 1 plus t square by 3t square. Let us do one more step here, LCM. So, limit t tends to 0, root of 1 plus t square minus 1 by 3t square into root of 1 plus t square. Okay, now, right. Again, here minus is there, no, plus, we will multiply and we will continue the solution. Okay. So, let us continue the solution. Welcome back to the remaining calculation. So, here also again multiply the numerator and denominator with root of 1 plus t square plus 1 by root of 1 plus t square plus 1. Okay, now. So, this is equal to limit t tends to 0. So, this is equal to a plus b into a minus b, a square minus 1 by 3t square into root of 1 plus t square into root of 1 plus t square plus 1. Okay, now. So, any more cancellations? So, here clearly plus 1 minus 1 can be cancelled. As t approaches to 0, t square approaches to 0, it cannot be equal to 0. T square approaches to 0, it cannot be equal to 0. That's why t square also we can cancel. Okay. So, wherever t is there, now you substitute here. So, what happens in the numerator? 1 we will get 3 into t value 0, 1 plus 0, 1, root 1, 1 into t value 0, 1 plus 0, 1, 1 plus 1, 2. So, on the whole 1 by 6. 1 by 6 is the final answer. So, here calculation okay, everybody can do. The thing is, this problem you can change into like this, limit t tends to 0, t into t plus log of root of 1 plus t square minus t by t cube. That is the idea that you have to get. If you do that directly, so very difficult to solve it. By directly, if you apply the L'Hopital rule, it's a very difficult. So, change the problem into like this, then we will solve the problem. Okay, na? So, dear students, I hope that you enjoyed today's class, all these 5 problems. Tomorrow, some more topics and some more problems I will solve. Okay. So, until then, all the best.